All right, Devoxx Ukraine. I'm glad you're all here. It's a little early in the morning. I know that a conference day with 8 hours of talks can be very exhausting, a lot of technical information to take in. So I promise you this one will not be technical. So just sit back, relax, and enjoy the ride. So who am I? As he said, my name is Chris. I work for a tiny little company called Twitter. And at Twitter, we have a VM team, and we have a couple people working on the JVM. And I'm specifically a compiler engineer, right? A lot of people might know what a compiler is, but let's ask the Oxford Dictionary what a compiler is. So it says, a person who produces a list or book by assembling information or written material collected from other sources. That's not what I do, right, obviously. But there's another definition that says a program that converts instructions into machine code or lower-level form so that they can be read and executed by a computer. And this is basically what I do, right? If we ask Wikipedia what is an optimizing compiler, because that's what I'm working on, you can see common requirements are to minimize a program's execution time. That's basically what we want. We want the thing to run fast. And then it also says minimize memory requirement and power consumption. And then it says in parentheses, it says the last two being important on portable computers, obviously, like laptops. We want our laptops to run as long as they can. We want our phones to last as long as they can. But the last two are becoming more and more important everywhere else as well in our data centers. And so this talk today, I call it performance. And it is about performance, but probably not what you might think. So this talk is about performance and our impact, right? So this is what I think software development looks today. I'm a little outdated. I'm an old guy. But so I don't even know what sprints are. So I had to ask the Atlassian website, what is a sprint? It's a short time box period where a Scrum team, I don't know what a Scrum team is, works to complete a set amount of work, right? And then there was this other snippet, this one, on the Atlassian website. It says, sprints make project more manageable, allow teams to ship high-quality work faster and more frequently, and gives them more flexibility to adapt change. I don't know, is that true? The thing I'm worried about in this statement is this, faster and more frequently. So that means you all get pushed and pushed and pushed to crank out the features, and the feature needs to be done today, and basically you have no time to think about something else. And the one thing that basically gets left behind is usually performance, right? Because you try to get the thing right and get it out the door, but you don't have time to actually make it good. So I have a small story. When I joined Twitter in 2016, I was told this story, so I didn't experience it firsthand. But there was a team, and they had an issue. They had too much memory pressure with their service. So what they tried to do was 2 or 3 people sat down for about 3 weeks, and they decided to eliminate as many object allocations they could. So they refactored the code and tried to get rid of all the object allocations. So to reduce the memory pressure and reduce GC times and everything. And after the 3 weeks, they refactored the code, and I'm sure it was not as readable and maintainable anymore as it was in the beginning. Guess how much memory they saved? Exactly, 0. And the reason for this is because there is a compiler optimization called escape analysis. And escape analysis already took care of all the objects they could eliminate themselves because the compiler could already prove you don't need them. So they're gone. So you should know your compiler optimization, and don't be too smart. That's usually what I tell people. People often ask me, so how should I write my Java code or my Scala code so that the JVM can compile it the fastest, the best? And my answer is usually write the code as it's supposed to be. Right? Don't be too smart. The compiler is not an AI. It cannot think. Basically, what the compiler is a pattern matching machine. If you break the pattern so that the compiler cannot recognize them, then it cannot optimize your code as well. So just write the code as it's supposed to be. You can read up all the optimizations on this Wikipedia page if you're interested, and maybe you should. Just skim over it once. All right, so let's talk about this one. Data center electricity usage. There's this page by Google, but if you search the web, you kind of find the same number on different pages, so we kind of can't believe it. And they say 2% of the world's electricity is used by our industry. 2%. It might not sound a lot, but think about it. It's all the electricity we use, and 2% of them is for our data center stuff, for the websites we produce, and all the e-commerce stuff and everything. So that's quite a bit. And this is the energy forecast. And we are now at 2019 over there, and we're looking at the green one, data centers. That's how much we use now. But projected in 2030, it's like 4 times as much, right? So we should think what we're doing in terms of that. So the good news with all the electricity usage is people are moving to the cloud. Rarely people have their own machines. And the cloud providers, they actually do some things to mitigate all this. So Google, already in 2017, so 2 years ago, they achieved their major milestone purchasing 100% renewable energy for all their data centers, which is nice, right? I mean, so they're doing their part. The problem is, if they purchase all the renewable energy, the rest has to use the other energy, right? So we're just shifting the problem around if we still continue using more and more electricity. I like this tweet about a month ago. So Google is building a new data center in Alabama. And the funny thing about this one, they're building the data center on a previously coal-fired power plant. So they tore the coal-fired power plant down, and that's where they built a new data center. I thought that's a nice move. Then Amazon, they also have a commitment to renewable energy, and they're not quite there yet. AWS exceeded 50% renewable energy usage for 2018, so they're kind of halfway there, or maybe now it's 2019. They're trying to build new solar farms, new wind farms to power their own data centers. That's good, because if they build their own their own power farms, they use their energy pretty close to probably where they have the data centers, and so the rest can use the renewable energy. So they built this, and then it's 2.9 million megawatt hours of renewable energy. So that's what they want to produce with all that stuff. Then Microsoft, I like this one, because we need an incentive to actually reduce our impact. And so Microsoft has this thing, it's called an internal carbon fee. And they doubled it just to $15 per metric ton of carbon emissions. So basically, teams inside Google, they have a budget, obviously. And the more electricity they waste, the more carbon emissions they produce, they have to pay for that, right? So that's a very good incentive to convince all the engineers working in that team to actually, think about that. The bad news is this. So this is from the International Energy Agency, and you can see all the different power sources. And you can also see that's from 1990 to 2017 or 2018. Energy demand increases, obviously, but you can also see that coal is going up and natural gas is going up. Hydro stays about the same. There's a chart that looks like this. That's basically in percentage. You can see coal basically stays the same. We reduced oil a little bit, but natural gas goes up because of all the fracking, and natural gas extraction is very cheap these days. Nuclear goes down because we're afraid of things. You, of all the countries, should know that best. Then hydro, yeah, it stays about the same. And then at the very end, we get a little bit of wind coming in. Solar is barely visible. So if you remember the other chart with the projected energy usage, the renewable energy will not do it, right? You remember this page, this guy? I want to talk about this guy because he's actually done something very interesting. Google used machine learning to reduce data center electricity usage, or energy in general. So in 2014, already the Google data centers used 50% less energy than other data centers because of the equipment they used. They just used more energy efficient equipment. That doesn't only mean the machines they're using, but also the cooling equipment and all that stuff. So, and then this guy, his name is, where's his name? Jim Gao. He just took an online class in machine learning and decided, hey, maybe we can use machine learning to figure a better way to set the data center up. And this is, you probably all know that, but it's every now and then we should look at it. So if you have 10 pieces of equipment with 10 different settings, that's 10 to the 10th power, or 10 billion possible configurations that you could have, right? A person, a human could not do this, but machine learning can absolutely solve that. And they did this, and then they have produced a 40% reduction in energy used for cooling. That's great. And a 15% reduction overall energy. So they used a little bit of machine learning, right? And they restructured the data centers and used 15% less. That's amazing. So we all should be thinking about this and doing this. And then they also say, where is it at the very end? They just scratched the surface of machine learning's general application. So I think we can use machine learning for other things as well to optimize whatever it is. So let me give you a Twitter example. Some people might have seen this before because I'm talking about this quite a lot. We use machine learning at Twitter to optimize performance. And that automatically means, so in this particular case, it's the tweet service. And by optimizing the JIT compiler, the flags of the JIT compiler, we reduce memory consumption by 7% per processed tweet, basically, right? This translates into 7% less GC cycles, which then translates into better P99 latency times, and that's about, I've integrated this out over the 24 hours, which looks like this. So we reduce P99 latency times by 28%, which then, this all combined, translates into this, 18% less CPU utilization, which means automatically 18% fewer machines and less energy consumption. So we do that. We do that at Twitter. We apply machine learning to reduce our environmental footprint. You probably know what that is, right? I kind of have to bring it up. That's a Bitcoin mining farm. So this was about a month ago where I looked this up. The energy footprint for one Bitcoin transaction, let's say today, it's probably a little more than that, 606 kilowatt hours for one transaction. That translates into 20 days powering a household in the US, 63 days in Germany, and 170 in China, so you can see how much energy an average American is wasting. That is 288 kilograms of carbon emissions, just for one Bitcoin transaction. And all summed up, there's the Cambridge University has this nice Cambridge Bitcoin electricity consumption index, 78 terawatt hours per year. It's a little hard to understand how much that really is. This number fluctuates all the time because it depends how many Bitcoins are mined today, right? But you can go on the website, it's like updated all the time. To put this in perspective, it's between Chile and the Philippines. The energy consumption of the country, Chile and Philippines, for 1 year. That's what we waste on mining Bitcoin. And these are the populations of these countries. So it's basically 30 million of Venezuelans, 101 million of Filipinos. This is ridiculous, right? Someone thought, oh, it would be funny to create this Bitcoin thing on blockchain, and then, you know, let's make it a little more funny. Every next transaction is a little more expensive than the one before. This is the outcome. And I've gave this presentation before, and someone came up to me and said, yeah, well, you know, Bitcoin, there are other cryptocurrencies today that don't use as much energy. And I said, yeah, okay, sure. But this is real. We're doing this today. This doesn't stop. This is a graph of the terawatt hours. You can see it on the y-axis. This is the graph how much energy we used since January 16, and you see it's going up and down. There are 3 lines here because the Cambridge University doesn't know what hardware people are using to mine Bitcoin, right? So the gray one at the top would be the worst efficient hardware, and the one at the bottom would be, everyone would be would be using the most efficient hardware to mine Bitcoin, and the one in the middle is what they think it is. And you can see this drop here, right, where we suddenly used a lot less energy. And if we put it in, you can hover your mouse over there. So it dropped from like 51 terawatt hours to 30. Do you know why? The reason is that the Bitcoin price dropped from $6,000 to $3,000. And suddenly it was not as, people didn't mine anymore because it was not financially viable to do it. So all the energy consumption we're doing is usually money-driven, right? If there's a financial incentive, then yeah, we don't do it anymore. This is a list of all the countries, how much it costs to mine one Bitcoin in those countries. You can't read that, but I pulled a few out. So you should move to Venezuela. If you want to do Bitcoin mining, move to Venezuela. The Bitcoin price right now is, I don't know, $7,000 or whatever it is right now. I don't know. Don't move to South Korea, right? I guess no one's mining Bitcoin in South Korea. It's also Bitcoin mining farms. It's an industry now. It's not a hobby anymore. People are building it in places where it's cold, so they don't have to do as much cooling and things. So it's a very complicated thing. So this is crazy, and this will not change as long as you can make money off of this, right? So Bitcoin is very interesting because there's a very interesting history behind the hardware people are using. And in 2009, the whole thing basically started. And the first Bitcoin miners, they used just multi-core CPUs, right? That's what they had. And it was much, much cheaper back then to mine them, so that's what they did. But already a year later, that was too slow, so people moved over to GPUs. And then the mining difficulty rose, so they needed better hardware, and GPUs could do that. And then already in the same, no, actually, well, it's not even a year between the two. It was so much more difficult to mine them that actually they had to use FPGAs. So GPUs weren't fast enough anymore, and then they already moved over to FPGAs. And in the same year, again, they built integrated circuits because the FPGAs weren't fast enough anymore. So it's very interesting because it's money-driven, we can actually improve a lot, right? We improved in 2-3 years from multi-core CPUs to integrated, dedicated hardware to do it. We could do this with other things as well, right? But the money isn't there. This is very interesting. It's game over for climate change. I like that tagline, right? So basically, video companies jump in the game. And it's very interesting to do this. So they make a couple promises. One of them is, they plant trees. Sure, that's nice. Reduce plastic packaging. Yeah, that would be cool. From gaming, or making game devices more energy efficient, I think that would be interesting. A lot of people running their Xboxes and PlayStations all the time, so if they would be more energy efficient, that would be interesting. To incorporating environmental themes into the games themselves. So basically, we would have games that encourage to think about the environment, and I think that's a very interesting approach with the newer generation growing up. With an estimate of more than 2 billion video game players. So this guy, Dave Paul, the Marshall Islands environmental minister. I don't know if you know the Marshall Islands. It's a small island nation in the South Pacific. And the Marshall Islands, combined with the Christmas Islands, will be the first islands to disappear on this planet. The sea level rises, and the islands basically what's happening. The first thing that happens with these islands is, they're not sinking. The first thing that happens is the freshwater table they have will be poisoned with salt water. So they don't have drinking water anymore. And the first thing that happens then is that plants die. So they have nothing to eat anymore. And then they have to move away. So this guy says, it's very interesting because 2 billion video game players. So this is the most powerful mobilization channel in the world. That's what he thinks. So that's a very interesting approach. This guy from Sony said they want to outfit the next generation PlayStation system with a low-power suspend play mode. I'm not exactly sure what that means, right? But he said if 1 million players use this, they could have enough power savings to power 1,000 average US homes. So there are things we can do to make things more energy efficient to save electricity. I want to come back to this slide real quick. We looked at the green one, but there's another one where the projection really skyrockets, and it's the blue one. And the blue one is networks, wireless and wired. So that means more and more data gets shuffled around, more wireless is coming, 5G is coming, and we are putting more cables on the ocean floors so we can transport data around. So what's becoming very interesting is data reduction and caching, right? We don't want to, if you watch a movie from Netflix, you don't want to stream the whole thing from, I don't know, from Silicon Valley, right? It should be cached somewhere locally, maybe in Kyiv, so you don't have to do so much data transfer. Which also means it's much cheaper, right? And also probably faster. So I'm using Twitter here as an example. I'm sure there are many more. We introduced about 2 years ago something called Twitter Lite, which basically uses less data. We didn't do this to save the world, unfortunately. We did this because of countries where data is very expensive. It's usually developing countries. They are still probably on 2G, and data is really, really expensive over there. That's why we introduced this. So again, I hate to say this, but we did this for money reasons, right? We didn't do it because we are a very nice company. We did it for money reasons. We introduced that feature then later in the actual Twitter app. So there's a thing called data saver mode. You can turn it on. I don't have it turned on, I'm sorry. So I turned it on only for the screenshot. But it reduces the quality of the image. It loads automatically. Then if you click on them, sure, it loads the whole quality, the full quality, HD. The same for video, and then the autoplay, right? If you scroll through your timeline, do you really need every video to autoplay? Probably not. But if everyone has that on, that's a lot of data that we have to shuffle around. So content delivery networks are already very important, but they will be more important in the future. As we've seen, if the projection is true, we need more of that. So I tried to look into what Google and Amazon and Microsoft are doing. And these are the data centers they currently have. These maps, I tried to find the edge nodes as well and put them on the map, but unfortunately they don't really have that data available. They have lists of cities where they have edge nodes, so it's usually big metropolitan areas. So this is not the whole truth, but this is where the data centers are. So it's very, very focused on North America and Europe, as you can see. There's only one in South America. There's none in Africa. And then we have a bit in China, Japan, and only one in Australia. And the picture doesn't look very different for Amazon. So again, North America, Europe, there's again one in South America. They plan building one in Africa, but still there's none today, and one in Australia. So we could introduce way more data centers around the world, and I'm sure they will do this, because otherwise the whole memory consumption, the whole electricity consumption of all these networks will explode. And this is Microsoft. North America, Europe, obviously one, and South America. They have actually 2 in South Africa. So Microsoft has way more data centers than the other ones. They have 4 in Australia, so they are expanding there much more. So that's cool. So as you can see, performance tuning actually has an impact, right? It's not something we do for fun because it's cooler to run things faster. They have an impact on our world. So everything we do has an impact. Bitcoin is the prime example for this. Something the guy didn't think, oh, I'll destroy the world. It was just a funny thing to do, but every now and then, maybe every now and then we should stop and think about the impact of our work. That's all I'm asking you to do. Thank you very much.